welcome back to my video. My name is Asima Sulys Simanjuntak. My ID number 41931111045. I am a college student from Mathematics Education Study Program 2019 and at State University of Medan. Now, I want to explain about Hindu mathematics development. Okay, the first I want to explain about history of Hindu mathematics. Hindu mathematics, or Indian, began with the emergence of a civilization located in the Indus River basin in the 26th century BC and ended in the 40th century AD. Indian mathematics developed after Chinese mathematics and before the emergence of medieval European mathematics. Indian mathematics, this civilization is commonly called the Indus Valley Civilization. The cities they lived in at that time were arranged geometrically. Around the 50th century BC, the Indians were exploited by the Aryans who came from Central Asia. For about 1000 years, the Aryans perfected Hindu writing and Sanskrit. Then was born Vedanta mathematics, which developed in India since the Iron Age. Around the 9th century BC, a mathematician named Sahatapatha Brahmin began to discover the value approximations, and then between the 8th and 5th century BC, the Sutras gave geometrical writing using rational number, prime numbers, the rule of 3 of the cubic roots. Calculate the square root of 2 parts of 100,000, provides methods of constructing circle whose area approximate a given square, solves linear and quadratic equation, develops Pythagorean triples algebraically, and provides statement and numerical proof for the Pythagorean theorem. In the year 555, Hindus discovered the number 0 and wrote the layout system for numbers. Indian mathematicians have long discovered the number 0, but there is no symbol for it. Then Aryabhata called the number 0 with the word Ka. Aryabhata has included 0 in the calculation system, not just an empty space. The Encyclopedia Britannica says Hindu literature proves that the number 0 may have been known before the birth of Christ, but no record is found with such a symbol ahead of the 9th century. The brilliant ideas of Indian mathematicians were further studied by Muslim and Arab mathematicians. Al-Khwarizmi was the first to introduce the use of 0 as a place value in base 10. This system is known as the decimal number system. And next, number 2, Hindu mathematicians. The first, Panini. It was Panini who formulated the grammatical rules of Sanskrit. The notations used is the same as modern mathematical notation and use the rules of meta, transformation, and recursions. And next, number 2, Surya Siddhanta. Surya Siddhanta introduced the trigonometric function of sine, cosines, and inverse of sines and laid down the rules that determine the true motion of celestial bodies, which correspond to their actual position in the sky. And number 3, Aryabhata at 499th century. Aryabhata is an Indian mathematician and astronomer. When he was only 23 years old, he had succeeded in making a great work, namely a book which he gave the title Aryabhatiya. Due to its popularity, it was translated into Arabic in the 8th century AD and then into Latin in the 30th century AD. Aryabhata also stated the relationship of the circumference of a circle to its diameter. And number 4, Gupta is a great Indian mathematician. His famous work is Brahma Siddhanta, which consists of proportions and rules. Besides that, there are also Brahma-Gupta theorems that are exact, namely by using Archimedes' Heron's formulas to determine the radius of the outer circle of a triangle. One example is when Brahma-Gupta made a formula equivalent to the trigonometric formula we use today, namely 2r equals to a divided by sin a equals to b divided by sin b equals to c divided by sin c, which is a reformulation of Ptolemy's work. Perhaps the most interesting result of Brahma-Gupta is to generalize from Byron's formula to determine the area of a rectangle, namely K equals to root of SA, SB, SC, SD. And next, Madhava is considered one of the greatest mathematicians astronomers of the Middle Ages and has made contribution to infinite series, calculus, trigonometry, geometry, and algebra. In the 14th century, Madhava of Sangamagrama discovered Leibniz's formula for P and used 21 terms to calculate the following value. Are we know? And next, number 3, Hindu number system. Indian numbering is based on base 10. There are several kinds of numbers in India, namely Brahmi numbers, Gupta numbers, and Nagari numbers. And I want to explain about the number 1, Brahmi numbers. Most of the positional numeral system that use 10 as the base used throughout the world are of India origin. The digit 1 through 9 in the Hindu-Arabic numeral system evolved from the Brahmi numerals. The Brahmi numerals are found on inscriptions in caves and temples in the areas near Pune, Bombay, and Uttar Pradesh. Different inscriptions, different form of symbol. Brahmi numerals have been in use longer and until the 4th century AD. Here is one style of Brahmi numeral, and we can see the picture. And number 2, Gupta numbers. The Gupta periods was the period during which the Gupta dynasty ruled all the way to Magadha in northern India in the early 4th century AD to the late 6th century AD. The Gupta numerals were constructed from the Brahmi numerals and were widely spread by the Gupta Empire. The Gupta number then develops into the Nagari number, sometimes also called the Devagari number. This is the form of the Gupta number, and we can see the picture. And number 3, Nagari number. Nagari number are often mentioned by Al-Biruni as most number because many were sent to the Arab world. Nagari numbers are often called Devanagari numbers. Indian numerals spread to parts of the world between the 7th and 16th century AD and have spread to Europe at the end of the 5th century AD. Here is the form of Nagari number, and we can see the picture. And number 4, inventions related to Hindu mathematics. There are several. 1, the Sulba Sutra, and the oldest records of Indian mathematics contain appendix to religious texts that give simple rules for building altars of various shapes, such as square, rectangle, and others. This appendix also provides a method for creating a circle by giving it a square that has the same area, and contains an initial verbal explanation of the Pythagorean theorem. And number 2, the Siddhanta Surya. Notes that introduce the trigonometric function of sine, cosine, and inverse sine, and lay down the rules for determining the actual motion of the position of celestial bodies. And number 3, Baksali manuscripts. The Baksali manuscripts is a manual of rules and illustrate examples and their solutions, mainly about arithmetic and algebra, as well as some geometry and measurement. The manuscript is estimated to have been complete around 400 m. And next, value Aryabhata worked on an experimentation on and may have come to the conclusion that is irrational. And next, research trigonometry. Trigonometry by Aryabhata in the book Ganitapada 6. Aryabhata suggests the area of a triangle, which means for a triangle, the result that is perpendicular to the half side is the area. And next, research algebra. Algebra by Aryabhata. And next, geometry, the basis and inspiration of the entirety of Indian mathematics is geometry. Geometry origination from India can be known through a record of the geometric construction of the Vedic scripts called the Sulbasutra. The Sulbasutra is a guide for the constructions of these altars for worship and explanation the history of Indian geometry. Hindu geometry is primarily for practical purpose. The first geometry regarding the erections of Hindu religious altars. The establishment of the altar is related to the Pythagorean theorem. Okay, I think that's all from me that I can explain about the topic Hindu mathematics development. If I have a mistake, I apologize. I hope I will be better in the next chapter. If there are a criticism or suggestion, you can write them in the comment column. Hopefully, this explanation video is useful for you. Thank you for watching and see you next video.